For question 7, we have a certain IV graph that is shown. We are supposed to figure out what is inside the box, or the black box, right? That gives us this IV graph. So you see this IV graph, right, is interesting. There is one part here, which is a straight line, and one part here where the current, right, shoots up. So it's as though, right, this part no more resistance. Yeah. Then the straight line part tells us there's a constant resistance. Yeah. The clear-cut answer, right, will be C. So let's go from here, right, to understand, right, why C will give us this. Well, the IV graph, right, for a resistor, right, will simply be a straight line. Okay, you got to realize, right, this graph will appear on both sides of the graph. Okay, the first quadrant and the third quadrant. Why? Because you could have negative potential difference as well, meaning, right, you switch the connections to the other way, then current will flow in the other way as well. So that's the negative part. Yeah. What about for the diode? Diode, right, will be 0 in the negative part. I'm just drawing it a little bit below. Okay, and here, right, it will be 0 as well until a certain value, right, then you'll start to go up. So together, right, when you put them in parallel, so current will think, right, you see, this portion here means, right, it is not welcoming to current. It has infinite resistance. Okay, yeah, so to speak. So in this region, right, up to the threshold being met, current will preferably, right, flow through the resistance. So it will adopt, right, this portion of the graph all the way until here. Okay, which is where, right, the diode starts to be welcoming. So once the diode starts to be welcoming, right, then current will prefer to flow through the diode and not prefer to flow through the resistance. Okay, therefore, right, from that point onwards, right, it will take on the shape of the diode graph rather than the straight line for the ohmic resistor. So that's the explanation for this.